Hello, today we are at Avalon Zoo and I am Forest Ranger Brandon with my team, Cars Anton and Forest Boy Matthew.
And today we're going to show you how to measure certain lengths without any measuring material. Hello, I'm Anton Mamuric, and today I'm here to show you, mountain climbers, how to measure the certain length of a lake without using measuring tools. First, you stay at the tip of the lake. Then you use this part of your cap to measure the water. Then you rotate your body to the left or the right until you only see land. Then you call a friend such as now to help you stay there. Stop. And then from here, you count your steps going there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And using that, you multiply it by your pace factor.
So that the number of steps and the length of the lake are the same. This will be my height. This will be the length of the lake, and this will be the length of number of steps I made. We can see that my height and the length of the number of steps I made form a right triangle, and my height and the length of the lake form a right triangle. And we can see that this side and this side are the same. This side and this side are this angle and this angle are the same. This side and this side is the same. So through this, we can prove that they are congruent through SAS. Thank you. That I made 25 steps. And my pace factor is 0.60. And if we were to multiply this, we would see that the length of the lake is 15 meters.
Hello everyone, I'm Brandon Hay and I'm here to show you a way to be able to get the height of a certain tall object. So first you get a pen and you get a ruler. Now you have to measure the length of the pen and you have to measure the length of your arm from your shoulder up to your hand. Next, you stand under the high object that you need to be able to get. Such as for me, I had to use a basketball court. Now you hold your pen here and you move your arm straight like that, but in a straight way, and you start moving back until the pen and the basketball court are at the same length. After that, from where you're standing, where it's the same length as the basketball court, you walk back to the basketball courts, and you count your number of steps, which mine was 19. Multiply that by your pace factor, which mine was 28 over 39.2, and you will be able to get the length of the distance from where you're standing is and the basketball court. Now I will explain to you on how to get the height of the basketball court after getting the distance from where you're standing is and the basketball court. So the height of the basketball court isn't missing and you don't know what it is. But you have this. This is the number of steps you are times your pace factor. Mine earlier was at 28 over 39.2, which is my pace factor, and my number of steps was 19. So if you multiply that, you get a number around 13.49. So that is the length over here, 13.49. And over here on the other hand, you have the length of the pen, which is given, which is at 14 cm, and you have your arm's length. Since you're holding it straight, first you have this right angle over here, and your arm's length, which mine was at 60 cm, is a proportion of the number of steps or the distance it was from point A to the basketball court. And this is a proportion of the basketball court. So we can say that both triangles are similar in the SAS congruency, or similarity statement. And now I will show you how to solve for the height of the object. First, since the length of the pen and the arm's length are proportions of the distance of point A to the object and the height of the tall object, we can use this type of solution. So the height of the object over the length of the pen is equal to the distance of point A to object and the arm's length. The height of the tall object is unknown, so we can use x, but the length of the pen is given, which is at 14 cm, but we have to use it in meters, so it will become 0.14 and equals the distance of point A to the object is also given, which was at 13.49 meters, and the arm's length was also given at 60 cm. Converted to meters will be at 0.60 meters. Now you cross multiply the two. You will get 0.6x is equivalent to around 1.89 meters. Multiply this both by the same number, which is 10, to make this not a decimal number, which will make it 6x is equivalent to 18.9 meters. Now divide it by 6, both of them, and you will get x is at 3.15 meters. So from there, we can conclude that the basketball court is at 3.15 meters, as x here is the same x over here. Done.
Can you borrow?
Hold
Where
on.
is it?
I don't have it.
Huh?
Okay, done.
Yeah.
Hi, I am Matthew Go, and today I'm going to be showing you how to get the height of a certain object using only a mirror and your own height. So the things we need to remember are that two angles are formed by you looking at the mirror and the tip are congruent, and the flagpole and you are congruent to the ground, making it a 90-degree angle. So if this is the pole and this is the mirror, this will be you, and you can see the reflection of the pole through the mirror, making these two angles congruent. And this is a 90-degree angle. And so I have to use my height, which is 1.72 meters, to find out the scale factor of the pole. So to find out the scale factor, we first need to find the height. You need to use my height, being 1.72 meters over the distance, 1.254 meters, equals x over 7.24 meters. These two are the distance. So when you cross multiply, it becomes 12.94 equals 1.254x. 10.32 equals x, being the height of the pole. The scale factor would then be 1.37.
I will show the video of how I attempted to measure the height of the pole without any measuring instruments, only using a mirror and its reflection of the certain object. Um, I will show how I counted my steps and show the attempt.